I want you to think about the moment you were born. Not the circumstances, not the hospital or the house or the country, not the people who were present, just the moment itself. The specific configuration of matter and energy that constituted your first second of existence outside the womb, the particular arrangement of atoms, that was you, newly arrived, drawing the first breath, making the first sound, existing for the first time as a separate entity in the world. Now I want to tell you something about that moment that physics says is true, that follows directly and unavoidably from the equations of special relativity, that has been confirmed by every precision experiment we have ever run, and that almost nobody ever says out loud when they talk about what relativity actually means. That moment has not ended, not in any poetic sense, not as a way of saying that birth is significant and significance persists. In a precise, physical, mathematically exact sense, the moment of your birth, the specific event in space-time that constituted your arrival, is not in the past in any absolute way. It is not gone. It has not receded into a finished history that exists only in memory or record, according to the structure of space-time as physics understands it. That moment exists right now, with the same ontological status as this moment, as any moment. It is happening, and it is accessible, in principle, to observers who are right now, as you read this, moving through space in the right way, at the right velocity, in the right direction. I know how this sounds. I know the immediate reaction is that this cannot be right, that the past is the past, that what has happened and is no longer happening, that the arrow of time is real and irreversible, and that no equation can change the fact that your birth was a long time ago and is finished. I understand that reaction completely. I had a version of it myself years ago, before I worked through what the mathematics is actually saying. The intuition is deep and it is wrong. Not wrong in a technical sense that can be safely ignored. Wrong in a way that means the universe is structured differently from how it feels, differently from how every human culture and every human language has always assumed. To understand why, we need to go back to 1905, not to the famous papers on photoelectric effect or Brownian motion, though both are important, to the paper that Einstein published that year on the electrodynamics of moving bodies, the paper that gave us special relativity, because special relativity does not just say that moving clocks tick more slowly and moving objects contract. Those are consequences. The foundation is something more radical, something that has been sitting in the equations for over a century and that still has not been fully absorbed into the common understanding of what the theory is actually claiming. The foundation is this: there is no universal present moment. Let me say that again because I want to make sure it lands. There is no moment in the universe that is objectively, absolutely, universally now. The concept of now, of a single slice through all of space that constitutes the present moment, of a boundary separating what has happened from what is happening, is not a feature of the universe. It is a feature of our experience. And our experience, as special relativity shows, with complete mathematical precision, is not a reliable guide to the structure of space-time. Here is the argument. In Newtonian mechanics, in the physics that preceded Einstein, time was absolute. There was a single universal clock ticking at the same rate everywhere in the universe. Two events that happened simultaneously in one reference frame happened simultaneously in all reference frames. The present moment was a fact about the universe, not a perspective on it. Einstein showed that this cannot be right. He showed it by taking seriously two things that seemed to be independently true. First, that the laws of physics are the same in every inertial reference frame, every frame moving at constant velocity. Second, that the speed of light is the same in every inertial reference frame, regardless of the motion of the source or the observer. These two statements, which seem innocuous and are both very well supported experimentally, turn out to be incompatible with the idea of absolute simultaneity. You cannot have both of them and also have a universal now. The mathematics makes this unavoidable. The demonstration is a thought experiment you have probably heard about, but I want to walk through it carefully because the detail matters. Imagine a train moving at high speed, and imagine a lightning bolt striking both ends of the train simultaneously, as judged by an observer standing on the platform beside the track. Both flashes happen at the same moment, from the platform observer's perspective. The platform observer is equidistant from both ends, and the light from both flashes reaches her at the same time. She concludes correctly from her perspective that the flashes were simultaneous. Now consider an observer on the train, standing at the midpoint of the train. This observer is moving toward the flash at the front of the train and away from the flash at the back. Because the speed of light is the same in both directions, and because the train observer is moving toward the front flash, the light from the front flash reaches the train observer before the light from the back flash. The train observer concludes correctly from her perspective that the front flash happened before the back flash. They were not simultaneous. Both observers are correct. The simultaneity of the flashes is not a fact about the universe. It is a fact about the reference frame. Different observers in relative motion disagree about which events are simultaneous. And if different observers disagree about which events are simultaneous, then the present moment, the collection of events that are happening right now, is different for different observers. There is no single universal now. There are as many nows as there are reference frames. This is not a limitation of our instruments. This is not an artifact of the finite speed of light. This is a structural feature of spacetime. The relativity of simultaneity is not about appearances. It is about physical reality. When we say that two events are not objectively simultaneous, we mean that there is no fact of the matter about their temporal ordering that is independent of the observer's state of motion. The temporal ordering of events that are space-like separated, events that cannot be connected by a signal traveling at or below the speed of light, is genuinely perspective dependent. Now let me connect this to the moment of your birth. Your birth was an event in space-time. It happened at a specific location and at a specific time, as judged from Earth's reference frame. Let us say it happened on a specific date, in a specific hospital, in a specific city. From Earth's reference frame, that event is in the past. The moment has passed. The configuration of matter that constituted that event no longer exists in the present. But Earth's reference frame is not the only reference frame. There are observers throughout the universe, observers on distant stars, observers on hypothetical planets orbiting galaxies billions of light years away, who are in motion relative to Earth. And for those observers, depending on their velocity and direction of motion relative to Earth, the event of your birth may not be in the past. For some of them, it may be in what corresponds to their present. For others, depending on their motion, it may even be in what corresponds to their future. This is not a metaphor. This is what the Lorentz transformations, the mathematical core of special relativity, actually say. For an observer moving at a sufficiently high velocity relative to Earth in the right direction, an event that happened on Earth decades ago can be in that observer's present or even in that observer's future. The event has not happened yet from their perspective. It is still coming. Let me put some numbers on this because I think the scale of the effect is important to appreciate. The relativity of simultaneity scales with distance. The further away an observer is, the more dramatic the effect of their velocity on which Earth events they consider to be in their present. For an observer 1 billion light years away, moving at a velocity of just a few hundred kilometers per second relative to Earth, which is a completely ordinary velocity for a galaxy, the events they consider simultaneous with their present moment can span thousands of years of Earth's history. An observer in a distant galaxy drifting at a few hundred kilometers per second in one direction might be simultaneous with events on Earth that we consider to be in the ancient past. An observer in the same galaxy drifting at the same speed in the opposite direction might be simultaneous with events on Earth that we consider to be in the future. Hermann Minkowski, who was Einstein's mathematics teacher and who gave special relativity its geometric formulation, described this in 1908 with a phrase that I find one of the most profound statements in the history of physics. He said that henceforth space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. What Minkowski was saying is that space-time is the fundamental thing. Not space, not time. Space-time. A four-dimensional continuum in which what we call events are points, what we call histories are lines, and what we call the present moment is a slice through that continuum whose angle depends on the observer's state of motion. Different observers slice the continuum at different angles. Different slices reveal different events as simultaneous, and every event that exists in the four-dimensional continuum exists in the only sense that the physics provides with the same ontological status as every other event. This is what physicists sometimes call the block universe, or eternalism. The idea that past, present, and future are not ontologically different categories, that they are not divided by a moving now, but that they are all equally real features of a four-dimensional space-time structure that simply is. The past has not ceased to exist. The future has not yet come into existence. The past and the future are exactly as real as the present. They are just in different locations in the four-dimensional space-time block. I want to acknowledge directly and without dismissiveness that this view conflicts with something very deep in human experience. We feel that the present is special. We feel that we are moving through time, that the past is receding and the future is approaching, that there is a flowing now that distinguishes what is real from what was real and what will be real. This feeling is so strong, so universal, so woven into the fabric of how we think and speak and organize our lives that it seems impossible that it could be an illusion. And I want to be careful here, because the block universe does not necessarily imply that the feeling of temporal flow is simply wrong. It implies that the feeling, whatever its source, is not a reflection of an objective moving now in the external world. The subjective experience of time passing may be real as an experience without corresponding to an objective feature of space-time. The question of why we experience time as flowing, why we feel ourselves moving through the block rather than simply being a line in it, is one of the deepest unresolved questions in the philosophy of physics, and I am not going to pretend it has a clean answer. But the physics is clear. The objective, perspective independent, now that our experience seems to require, does not exist in the structure of space-time as special relativity describes it. Now I want to go further, because the block universe interpretation of special relativity is not the only place where physics challenges our intuitions about past and future. Quantum mechanics adds a layer to this story that is, in its own way, equally disorienting. In quantum mechanics, the state of a physical system before measurement is not a definite configuration. It is a superposition, a combination of multiple possible configurations, each with a certain probability amplitude. The act of measurement, whatever that means physically, resolves the superposition into a definite outcome. This is the measurement problem, the deepest unresolved problem in the foundations of quantum mechanics, and I am not going to pretend it is resolved. But there is a consequence of quantum mechanics that is directly relevant to the question of the past. In quantum mechanics, the state of a system at any given time encodes probabilities for the outcomes of measurements. Those probabilities are not simply records of what has already been determined. They are genuine uncertainties about the state of the system. And here is where it gets interesting for our purposes. In some interpretations of quantum mechanics, including the relative state interpretation developed by Hugh Everett in 1957, the past is not simply fixed. It is defined relative to the state of the measuring system. The history of a quantum system is not a single determinate sequence of events, but a branching structure in which different outcomes of measurements correspond to different branches of the universal wave function. In the Everett interpretation, your birth was not a single definite event. It was an event in a particular branch of the universal wave function, the branch that corresponds to the world you experience. Other branches exist, branches in which your birth went differently, branches in which aspects of that moment had different outcomes. Those branches are not in the past in the way we usually mean past. They are part of the current state of the universe, encoded in the universal wave function, as real as this branch in the sense that nothing in the formalism of quantum mechanics distinguishes them. I want to be precise about what I am and am not claiming. I am not claiming that you can access those other branches. I am not claiming that the you in this branch can see or interact with the you in another branch. The branches are causally isolated. But I am saying that the physics suggests a picture of the past that is more complex than the simple receding linearity that our experience implies. The past in quantum mechanics, as in special relativity, is not a simple, finished thing. Let me now bring these two threads together, the relativistic block universe and the quantum branching structure, and ask what they jointly imply about the moment of your birth. From the perspective of special relativity, the event of your birth is a point in the four-dimensional space-time block. It exists in that block with the same ontological status as the event of this moment. For observers in distant galaxies moving in specific directions relative to Earth, that event is in their present or their future, not their past. It is still approaching them, still about to happen, still not yet done. From the perspective of quantum mechanics, the event of your birth was a measurement-like interaction that selected one branch of the universal wave function out of the superposition of possibilities that existed before it. The other branches, the counterfactual versions of that moment, continue to exist in the universal wave function, not as memories or possibilities, but as real structures in the current state of the universe. Put these together, and what you get is a picture of the moment of your birth that is not the simple, finished, receded into history event that it seems to be from inside the flow of your subjective experience. It is an event that, in some reference frames, has not happened yet. It is an event that, in some interpretations of quantum mechanics, continues to ramify into branching structures that persist in the universal state. It is an event whose complete description requires four-dimensional space-time coordinates rather than a single timestamp. And it is an event that, as a point in the four-dimensional block, has not gone anywhere. It is still there. It is still happening. Not from your perspective, not from Earth's reference frame, not in the experiential sense, but in the physical sense. In the sense that the mathematics of our best theories of nature provides. Now I want to take you somewhere that is less about the formal physics and more about what this means for how you understand yourself and your place in time. Human beings have a particular relationship with the past that I find, when examined carefully, philosophically remarkable and somewhat strange. We treat the past as fixed, as finished, as more real than the future precisely because it has already happened. Memory, history, causality, they all point backward to a past that we treat as the solid ground of reality, the foundation on which the present stands and from which the future will emerge. But the physics suggests that this solidity is perspectival. The pastness of the past, The finished quality that makes it feel so different from the present and the future is a feature of our reference frame, our causal situation, our position in the space-time block. From inside the block, the past feels gone. From outside the block, if such a perspective were available, every event would look like every other event. No more past, no more future, just the four-dimensional structure with every event at every location equally present. This has implications for how we relate to events in our own lives. The moments that we grieve, the moments we regret, the moments that we would give almost anything to have back, those moments are not gone in any absolute sense. They exist in the space-time block. They exist in other reference frames as present or future. They are as real as this moment. They are simply not accessible from where we are, moving forward along our world line through the four-dimensional structure. I am not saying this to comfort you in a false way. The inaccessibility is real. The asymmetry of causality is real. You cannot go back to those moments, not because they do not exist, but because the causal structure of space-time, the light cone that defines what can influence what, prevents it. But there is a difference between inaccessible and non-existent. And the physics is telling us with considerable precision that those moments are inaccessible rather than non-existent. The moment of your birth is not gone. It is inaccessible from your current position in space-time. It is behind you causally. It is in the past of your reference frame. But it is not nowhere. It is not nothing. It is a point in the four-dimensional block that physics says is as real as any other point. It is being approached right now by observers in distant galaxies who do not yet know it has happened, who will experience it as a future event that becomes present and then past as they move through their own proper time. And it will remain in the block forever, as permanent and as real as any other event in the history of the universe. I want to follow one more thread before we close, because I think it is the most personally resonant part of this story. If the moment of your birth has not ended, if it persists in the four-dimensional block, then something else follows. Every moment of your life, every experience you have had, every memory you carry is a point in that block. The moments of joy and the moments of grief and the ordinary, unremarkable moments that constitute the vast majority of a life, the moment you learned to read, the moment you first understood something that had been mysterious to you, the moment you realized someone loved you, the moment you lost someone, every moment is a point in the block. Every moment persists in the same sense that the moment of your birth persists. From inside time, moving forward along your world line, these moments feel like they are leaving you. The past feels like it is receding. The moments feel like they are becoming less real as they move further into the past. But that is the view from inside the flow. The view from the structure of space-time is different. Every moment you have ever lived is still there, not accessible, not changeable, not returning, but real. Permanent, as present to some reference frame, somewhere in the universe as this moment is to you. There is a version of this thought that I think is genuinely important and that does not require you to accept all the philosophical implications of the block universe. Even without the full block universe interpretation, even if you think the physics merely shows that simultaneity is relative rather than that all moments are equally real, you are left with this. The moment of your birth and every other moment of your life happened. It is part of the causal history of the universe. The light from the hospital room where you were born, the photons that scattered from the walls and the faces and the equipment of that moment is right now spreading outward through space at the speed of light. Those photons carry information about that moment. They are the physical record of your birth, moving through the universe at the maximum possible speed, reaching further and further into space. The light from the moment of your birth is right now passing through space somewhere. It is not at the location of the birth, not near the Earth, but somewhere between Earth and whatever lies 20, 30, 40 light years away, depending on how old you are. Those photons are the physical trace of that moment, moving through the universe, passing through interstellar space, perhaps passing through the atmospheres of exoplanets, certainly being scattered and redshifted and mixed with other light, but moving real. The electromagnetic record of the moment you arrived. If there are observers within that shell of expanding light, observers on planets within that distance, they have not yet received the light from your birth. That moment is still in their future. And when the light arrives, if those observers had instruments sensitive enough to detect and analyze individual photons scattered from a hospital room or a home birth on a distant planet, they would see the moment happening. They would see it as present. Of course, the photons from your birth are hopelessly mixed with billions of other photons from Earth, undetectable, practically speaking, by any observer anywhere. This is not a practical suggestion for how someone might watch your birth. It is a physical statement about what the light is doing and what it means about the permanence of events. The information is there, it is moving, it has not been destroyed. The universe keeps records, not intentionally, not selectively, but the physics of information and the physics of light mean that every event in the universe casts a shadow of electromagnetic radiation that propagates outward indefinitely. The shadow fades, the photons scatter, the signal dilutes below any practical threshold of detection, but they do not vanish. They do not stop being real. They continue spreading through the universe, carrying the imprint of the moment that produced them. Your birth cast a shadow of light into the universe. That shadow is still moving, still real, still out there, somewhere in the dark between the stars, carrying the physical record of the moment you arrived. And somewhere in that spreading shell of ancient photons, the moment of your birth is, in the only sense that physics can give that phrase, still happening. I find that when I sit with it carefully, one of the most extraordinary things the physics of space-time has to say about the nature of existence. Not the most practically important, not the most immediately useful, but among the most philosophically significant, because it means that the moments of a life, all the moments, are not consumed and destroyed by the passage of time. They are woven into the structure of space-time. They propagate through the universe as light. They persist in the four-dimensional block as events that other reference frames can access as present or future. They are not gone. They are simply no longer here in the only reference frame from which they ever felt immediate. Time is not a river carrying things away from you into a void. Time is a dimension. And the events in that dimension, including the moment you were born, are as real and as present as any point in space. You do not look at the chair across the room and grieve that it is over there rather than here. It exists. It is real. It is simply at a different spatial location than you are. The physics of special relativity is telling you that the moments of your past are analogous to that chair. They exist. They are real. They are simply at a different temporal location than you are. And for observers at the right spatial locations in the universe, moving in the right ways, those temporal locations are not in their past at all. The moment you were born has not ended. It is still happening somewhere in the universe, in all the senses that the physics of space-time allows. And that, I think, is worth knowing. If this changed something in how you think about time, about the moments you have lived, about what the past actually is, I want to hear it in the comments. Tell me what moment in your life you find it most meaningful to know has not truly ended. Tell me whether the block universe feels like a comfort or a constraint. These conversations shape where we go next. And subscribe if you want to keep going deeper into the physics that changes not just how we see the universe, but how we see ourselves inside it.